Welcome back, everybody. This is lesson 1-2, part C, our third type of display of quantitative data called stem and leaf plots. So our goal for today is to be able to construct a stem and leaf plot. So we're going to do a little introduction to it today, and next time we'll go into more detail with different things with stem and leaf plots. So with that being said, quick review. Different types of quantitative data. We have talked about continuous and discrete. Discrete is those mostly whole numbers, and continuous is where you can have all the in-betweens. We also talked about interval versus ratio. So interval is the types of quantitative data where like zero doesn't necessarily have its true zero, where it's like a start or a nothing, but it is usually part of it. The other thing is ratios don't quite work, like twice of something or half of something, not really making sense with interval data, like temperature. That's a good example of it. Whereas ratio data is data that has a natural zero. Zero means nothing. You can multiply something by 2 or take a half of something and it actually makes sense. So like sizes of things, weights of things, heights of things, ages, those typically are ratio data. Let's look specifically at stem and leaf plots today. I have an example to the right, but a stem and leaf plot is where quantitative variables are partitioned into a stem and a leaf, which is why it's called stem and leaf plot. Like all good mathematicians, it's a real creative name. But it's kind of like a sideways dot plot, but instead of dots, it's specifically the numbers. You can fit more numbers. If you look at the one to the right, it gives a little key where it says 4 and then the bar 80 means $480 of income. So you can put a whole bunch of things in here, which means right here, we've got 410 and we've got 480. These are two numbers in that thing. So you can figure out exactly what all the numbers are. Over here this is 890. This one we've got 710 and we've got 730. So these are all numbers with the stem and the leaf, and you can kind of decide what the stem is to make it appropriate for a stem and leaf. All right? Now, certain criteria must be met in order to use a stem and leaf plot. Here's a couple of them. So first of all, the data must be discrete. So there's some ways around this, but and you can kind of use some decimals, but generally it should be discrete data. The leaves must be the same size, meaning we want to have single digits or double digits. We want them to be the same size for the leaves. Leaves must go in ascending order. So if you look back at the top, we have, like in the 2, it's 240, 260, 270. It's in ascending order. There can be multiple of the same one. No commas between the data values, just like a space. You should have a title and a key are necessary, so we know what's being talked about here. And like a histogram, we only want like 5 to 15 intervals. There must be data in the starting and ending intervals as well. There can be gaps in there, but the starting and ending intervals, must have data, and we don't want too many intervals. So let's take a look at our first example, where it says we've got some data in responses to 20 female AP Stat students who answered the question, how many pairs of shoes do you have? So the data is there. That's the raw data. But to create a stem plot or a stem and leaf plot, we need the numbers in order from least to greatest. So step 1, I'm going to say, is order your data. Okay? Take them in order from least to greatest. And if I scroll down a little bit, I already did that. There's my data in order from least to greatest. All right, step 2, we want to create stems. If you notice, it goes from 13 all the way up to 57. We could have the 10s, the 20s, the 30s, the 40s, the 50s. That's 5 stems. That could work. Okay? Now let's make a key and a title and add the leaves in order. So What I'm going to do, I have the data already listed here in order from least to greatest. I'm going to make my stem and leaf plot. So I'm going to start by just making a nice bar here, a nice line. I'm going to say 1, 2, 3, 4, 5. And this is going to be, my key here is going to say, let's actually do one. I've got 1, 3, I've got a 13, another 13, another 13, a 15, a 19. So I'm going to say 1 bar 9 means 19 pairs of shoes. All right. Now, I want a title. Question is, how many pairs of shoes do you own? So I'm going to make that my title. Probably should have done some capitals there, but I'll fix that later. And since it's already in order from least to greatest, it's going to be really easy to fill this in. I've already got all the teens done. Let's go to 20. We've got 22, 23, 23, 24, 26, 26. There we go. Now, since I'm using this on a grid, the lines kind of break up the different values. If you didn't have that, you'd probably have to leave a little bigger space between each number so we know it's not, so we know they're all individual numbers. Let's go into the 30s. We got 30, 31, 34, 38. We got 49. We got 50, 50, 51, 57. There is my data. There is my stem and leaf plot. I should probably add on here. Stem, leaves. But if it's not there, that's okay. We get the point. I've got my key, I've got my title, I've got all my data. And this, if you turn it sideways, can be used as a distribution to describe the distribution of this data. Right? So if I were to take this whole thing, which I don't know if I can easily do that, let me try something here. All right, I've got this. I'm going to take this. Whoa. Did not do what I meant to do. And I turn it. Now I have my distribution of data. Really, you don't have to do it like this, but visualize it sideways. My data kind of goes like this. And it's pretty tall, so like really then it just drops down, and it drops down here. But that's my distribution of data. It's fairly symmetric. Has a peak in the 20s. You know, there's no clear outliers or anything like that. So we can look at SOC-V from one of these types of graphs. So let's describe it. If I were to, that's what my next question is, describe the distribution of number of shoes female students have. I would say it is a little bit skewed right. So if I'm going to go down my SOC-V shape, I want to say the distribution of pairs of shoes is slightly skewed right. And we'll just say there's a peak at in the 20s. Outliers. I don't think there's any clear outliers. Or clusters or gaps. There's a slight gap in the 40s. So from 38 to 49, we could say that. No clear outliers. We'll say gap from 38 to 49. Let's see, the center. I got to go down my list, but I could also just take my numbers that I had in order from least to greatest and then it's right in between those two, so it would be 26. So my center is at 26. Median. So median at 26 shoes. And my variability, the last thing, we'll say the range is, what is it, 57 minus 13. So 44 shoes. Well, I'll say it pairs. But that's that 57, man, 57 pairs of shoes, that's a lot. Minus 13 gets you 44 pairs of shoes as the range. So that's my distribution. We can do this with any sort of data distribution when we're dealing with these quantitative data. So now that we did one together, I want you to take a look at this one other example because I'm going to go through this quickly because this one does have decimals, so you can do it with decimals as well. This is data on average income and pupil to teacher ratio of a lot of the school districts around us in our area. And we are on there right here. This might be from a couple of years ago. But what I want to do is make a STEM plot of pupil to teacher ratio. And those are all decimals. So there's a way to do it with decimals. First, same deal, put it in order from least to greatest, and I did that. It's 12.9 all the way up to 17.7. So now if you look at it, you can maybe guess what the stems are going to be. I'm going to use the whole numbers, the 12, 13, 14, 15, 16, 17 as my whole numbers, and I'm going to make the least everything else. The way to work around this, so that we know it's not like 129 and 130, is the key. It says 15 bar 2 is pupil to teacher ratio of 15.2. So you can do it with decimals, and I have 6 stems, 6 different categories. That's fine, and that'll work. And I can also then look at the distribution of this data. Kind of goes down a little bit there. I don't know, it's somewhat symmetric, not very good though. It's more skewed left, I would say, maybe a little bit bimodal. So this is the look of a stem and leaf plot when you have decimals. Okay? And again, same deal. You can describe the distribution from this. So that's just our introduction to stem and leaf plots. We're going to do a little bit more with that in the next video. We'll look at some different variations of stem plots from there. So that's lesson 1, 2C, day 1. See you next time.